Good day, everyone. My name is Michał Kłakowski, and I'm going to talk about the cloud-native journey with GitLab. Today, I'm here as a stand-in for Adrian Waters, who is a EMEA channel solutions architect. In my daily life, I deal with channel as well on a global scale. And I'd like to tell you a story about what GitLab is, and you might be surprised in a couple moments because very often people think about us with certain perceptions based on our history, but it's not exactly where we are going and we want to be. So I'll share a little bit of GitLab vision with you. Then we stop briefly around something that everybody knows already, which is what is cloud native and why some apps are considered cloud native. And then we'll jump straight into the essentials, which is what is the advantage for the developer, for the DevOps, and for the company as a whole of applying DevOps platform, which GitLab is, to their processes. So let me start with this right away. First of all, many companies are now undertaking the digital transformation. Practically everybody is doing something in this direction, but few companies are happy with the results. Why is that? We all have that feeling that it is sort of a race. Who is going to adopt that brave new world of cloud applications first and be able to digitize processes, digitize customer touch this way? Quite a large percentage of companies are stuck in that journey, and there is a reason for that. Number one of those reasons is that part of the journey is decomposing application. So some of those applications will be brand new and written this way, but for most of them, that is the existing digital process that we're willing to take to the cloud. And on the way, we want to decompose that to smaller microservices because that is the way that you integrate in the cloud, and that is the way you distribute workload among teams in the cloud. And to give you an example of that multiplier, which applies here, S3, which is a simple storage service from Amazon, launched in 2006 with just 8 microservices. Right now, there are over 300. Each microservice developed by a separate team and bringing in their separate complexity. Number two is that the tooling landscape of the individual team is getting more complex over time. So everybody is used to the fact that you need some sort of planning for the work and code repository and maybe CI. But then the continuous delivery concept came in. And then all of the security scanners, numbers of which is only growing over time as we adopt to protect our applications from new risks. We have, static application code security testing, dynamic application security testing. We search for secrets. We look at the fuzzers to improve the security posture. We scan for dependencies. We scan for rogue images. We scan for existing vulnerabilities in our dependent libraries, and so on. The list goes on. This only adds to the complexity of the toolchain that developers are using. And every new complexity slows the whole process down. When you combine the two, you are getting at least geometric complexity, which grows over time and adds friction to that process and slows everybody down. So thinking about the solution to that, there is certain maturity in the process which needs to happen so that we flatten this curve. And historically, it all started with every team bringing their own tools and assembling whatever fit them, which is great and efficient for the team, but it does not really allow for intra-team collaboration. And in the world of microservices, this is necessary. So next step is then the company standardizing a little bit on those tools so that people at least do not have that mental effort of switching from one type of tool to the other and learning the concept. And eventually, in the phase 3, which is called do your own DevOps, companies start integrating those tools. But integrating them is hard because they do not operate in the same concepts. You need a fragile extract, transform, load type of integrations. They're not exactly real time. You're really having different user concepts, different databases across the whole landscape. And the result is that it takes a lot of work and is never up to date and is particularly never secure. So here we're entering number 4, the DevOps platform era, where GitLab is really the promoter and out there to say inventor of that concept, where we say you don't really want to reinvent the wheel that hundreds other companies or thousands other companies are doing already. What you need to do is adopt the platform and start focusing on something which is unique to your business, which is unique to your industry, because this is actually the problem worth solving. And as GitLab, we are the DevOps platform. Now, if you look at the analysts, they are saying that the amount of the percentage of adoption of those platforms, of a platform concept, is growing rapidly. By 2024, 60% of organizations will be there. The difference between GitLab and the others is really that everybody is now racing towards this concept, but we have been here since the beginning. That is our original idea, how DevOps should be done. And my last slide about GitLab as such, the return on investment of switching to platform is progressive. First, obvious type of returns are reducing the costs related to purchasing other tools, to managing infrastructure for them, to supporting them, to vendor management, all that overhead which relates to maintaining a complex software beast that the modern tool chain is. But then, in the next step, as you adopt it, you start realizing that there is better developer experience, which essentially helps you in 2 ways. Number 1, developers are more productive, so you get more velocity out of your existing teams. But number 2, and that is often overlooked, developers are happier because they don't have to struggle with things which are slowing them down, and they want to work for you, which means there is less churn and there's easier to attract talent. And then at the level 4, which is really a cultural shift, you start observing revenue acceleration because you can innovate faster, because launching a business experiment becomes all of a sudden easier. There is no friction, there's no overhead to just code something, try it quickly and see if it works with your customers. So how does this apply to cloud native? Well, when we think about cloud native technically, the application is certainly containerized, it's scaling out in arbitrary cloud or clouds. It has properly externalized dependencies and config. It is obviously loosely coupled with other microservices. It exposes a well-defined and stable API. It would have its configuration and potentially infrastructure managed as code. So you're now not talking about just digital application, you're talking about the whole digital service or digital product as a whole. It is delivered in a continuous way without necessary friction by comparatively small teams which are able to work together on individual components. And important thing to consider is that getting there does not happen overnight. When you think about existing application landscape, which is now being moved to cloud, you essentially, you can lift and shift the whole up to the cloud. But in order for it to become cloud native, it undergoes through that strangling the monolith process, where gradually over time, certain functionalities are developed outside of it as individual services, and monolith becomes smaller and weaker over time, and eventually it either becomes a functionality which is a commodity and can stay there, or becomes strangled to death and can be replaced by a bunch of microservices. That is how you really architecturally adopt existing app to the cloud. It's a process in which GitLab can help in at least 3 ways. So as said in the agenda, let's start with the advantage for individual developer or individual team. Number one, GitLab is really quick to start with because it's a platform. It has a single database. It has a single UI. Once you get onboarded, you right away get all your rights or all your necessary components to work with. All the templates that you might want to use for the projects or for the issues or for the code or even for the CI or CD. And there's a feature called Auto DevOps, which helps you do that. Auto DevOps is a library of templates which are supposed to build CI/CD. So, for example, you don't have to reinvent the wheel. How do you integrate with your security scanners? All of the necessary files to enable them are in your library right away. It's just enough to import them to your template and start working with them. And we do have templates for most of the frameworks and languages out there ready for customizations. And then once you adopt it, you obviously need everything as code, and pipelines is not an exception from that. And because you're working in multi-project environment where every microservice is represented either by a separate project in GitLab or by a separate folder within a large monorepo, you need a way to combine those pipelines from multiple projects flexibly and trigger them on certain conditions, like, for example, only when there was a change in that project. And that flexibility is there. And eventually, I'll show you an example soon. The super important stuff, but really critical, is the review apps for each commit. Most of the traditional environment have limited number of environments available for you to test on. So that means that, for example, when you're moving from your individual branch to a larger, merging back to master, you're going to get a result of your security testing only like 2 weeks after you finished your work. Now, I can't remember what I had for breakfast today, let alone what I've been doing 2 weeks ago. So when I'm thinking about life of developer, it is kind of important to get the feedback for your work right away. And review apps enable just that. It's a complete environment that you can have for every application component, for every feature branch, provisioned dynamically on Kubernetes, and we'll get back to it. So now that is the example of the pipeline, which is developed as code. In GitLab, you have all the stages defined in either one YAML file or a collection of YAML files, and it eventually builds up for a project pipeline. Those pipelines can actually trigger the downstream dependencies. And as you have noticed here on that right-hand side, this pipeline is actually executing, building a review environment and executing some dust on it, which is dynamic application security testing. So you're going to get all that data fed back into merge request, and the review team will be able to look at it, potentially look at the actually provisioned application and see if they're happy to merge it back to master or not, which is a way to make sure that master stays green and you have a quick, short lifetime for a feature branch. And to give you some example, we have a customer who is making cars, and this customer has been using GitLab to develop components of its infotainment system. Now, they have been able to significantly speed up the build time and the number of releases. But what I want to highlight here is that the time for onboarding new application, new front-end component to the CI/CD system dropped from days to 30 minutes. That is the time that the new front-end team needs to come up and start experimenting with a new component. And that is, if you think about the culture of business experimentation, that is significant. Now let's switch sides a little bit and wear a DevOps hat and think, how can GitLab help in this area? Well, number one, we have basically integrated with Kubernetes from the very beginning. And the nature of that integration changed. Before, it's been more of a GitLab manages Kubernetes and needs all the keys to the kingdom type of integration. Right now, because we realize in the enterprise environment, sometimes it's a production cluster and it's a security issue for GitLab to manage that cluster, we have the reverse type of integration where GitLab agent is running on a cluster and monitoring changes, GitOps style, and fetching them and applying them. And it's much easier to roll out in enterprise scale. It helps you do infrastructure as code. It helps you do policies as code, like, for example, Anthos policies. Google has an article on that. How do you use GitLab to manage Anthos at scale? And it also helps you manage all the pre-integrated apps which really create that landscape in which you're deploying your application. So, for example, Prometheus for monitoring, Elasticsearch for log aggregation. You can also add your own apps to that management structure. It's all managed as code, so you essentially have the same feature branch plus merge request type of governance control over who is doing what in that environment. And it also helps with canary releases. So now to jump into some examples, here is our environment board where you are seeing a staging and production for an application. You see what has been deployed there and when in terms of branches. What is the amount of pods? What is the state of these pods? Do you have any canary pods which are carrying a newer release? With the icons on the right-hand side, you can jump to the terminal logs or the actual environment right away, and you can decide if you want to roll back to a previous release. It's all on a single screen, assuming you have proper rights in GitLab. And when you move to a particular environment, because we have Prometheus in there and because we have Elasticsearch, we can fetch back the information and present it again in the GitLab UI. So you're getting the monitoring showing you what is the performance impact of a particular release on that individual application. So there's not monitoring of the whole Kubernetes cluster. There's a monitoring in context of a particular namespace which are representing your new application environment. And the same thing happens on the right-hand side where you have a namespace representing production environment for a given application and a bunch of pods which are sitting in there for individual components. Now, there is also a higher overarching advantage of using GitLab for a cloud-native journey. And we have been talking about removing friction at the scale of individual teams, but it's also GitLab can become a collaboration platform for all those teams in between them. So because of that built-in transparency, developers see the actual state of infrastructure. Operations can see particular commits into the application branch. Security can stay there and basically just provision tools for everybody to use, not necessarily being called for every single vulnerability, because some of them developers will know how to fix, but still they will retain the visibility of the whole risk platform. To give you an example, developer we might configure this platform in a way that developer can mitigate vulnerabilities which are not critical themselves. Security would still see them, but this mitigation could be twofold. Either developer fixes that vulnerability or they dismiss it if they think that the risk related to that vulnerability is not really surfacing in production environment. So that hands back the control back into developers' hands under the oversight of security. Same for license compliance. Licenses can be tracked and monitored by GitLab because every single build goes through that platform. There is a low overhead with this, low operational overhead to maintain this because it all comes as a single platform. GitLab is also quite special company to work with. What you see on the right-hand side is our maturity page. That's a single page listing all the categories that we think we operate in, all the stages of the DevSecOps life cycle, and our perceived maturity, and it's a drill down. So you can click on those and get into the relevant category pages, then epics, then particular issues. It's all developed in the open. So if you have your own opinion on that, you can go and start commenting on this. Alternatively, if you think you know better, you can contribute to it and give us a merge request ready to merge, which has the advantage for you that you're not going to maintain the functionality separately, but instead develop something and hand back to GitLab. And for us, this creates additional market visibility and momentum. And right now we have more than 2,500 external contributors which are working with us on a daily basis, mostly in the enterprise space, because they think that it's worthwhile to put their own ideas into how GitLab is built. GitLab is also truly cloud agnostic. We can deploy on any cloud. We can have our workloads, our runners, or on the CI/CD bots, which are executing the jobs on any cloud, and we can deploy applications, be it cloud native or not, to any cloud as well. So that helps with the multi-cloud strategy and helps stay equally effective with the same type of process, same type of governance across the clouds. And to give you some examples again for that, we are right now advanced technology partner with AWS, which is the highest possible type of partnership you can have with them in that area. Google has selected us their favorite partner this year for application and development. This shows that not only we are bringing value to the end customers who are undergoing that transformation, but we're also helping our cloud partners move with their migration, and they value us for this. So that is much more than just yet another tool you can use on those clouds. We have a tight collaboration with cloud vendors, and we're working together on joint solutions on a daily basis. So the intellectual property is there for you to use. And again, to give you some recent example, the UBS, the Swiss bank, one of the largest in the world, has chosen GitLab as their global DevOps platform recently, and is transforming the way they build their applications with us, realizing all those strategic advantages that you have seen before. That is all I have prepared for today. Thank you for your attention and have a great day.